Hi everyone, Victor here again, and in today's lesson, we're going to be looking at what Ingress is and what Ingress controller is. We're also going to be looking at what meta load balancer is and why they matter and when to use them, and also how to use and configure them. So the first question would be, why do we need Ingress? And you would agree with me that whenever you deploy applications on Kubernetes, you usually want them to be accessible from the outside, meaning that wherever you are, outside of the Kubernetes cluster itself, you want to be able to access your applications. And by default, Kubernetes gives you a few options to expose services. And one of the options is to use the node port type of service, and another option is to use the load balancer type of service. And those options are limited. They come with their own limitations. So to use a node port type of service, that means that you would need to open the port the service listens on each node, and that doesn't even scale well. And also to use a load balancer type of service, that means that you need a cloud load balancer that will be able to assign IPs to your load balancer type of service. And not even all cloud providers have that capability. So some cloud providers does not even have the cloud control manager to be able to do that. And aside from that too, having a cloud load balancer, it can also be costly, especially when you're using it per applications you're going to be built. And that is why this method doesn't really scale well. And that is why we need Ingress. So Ingress is that Kubernetes resource. And when I say Kubernetes resource, I mean that kind of Kubernetes resource. Just like when you have your deployment YAML file, in the kind section you have the deployment as the kind parameter. If you have a service, you have a service as the kind parameter. So the same thing is applicable to Ingress. Ingress is a Kubernetes resource that helps you to route applications externally via HTTP or HTTPS. And and it can also be based on host names or paths. So it's scalable, and it works well. And you can either use one IP or even a domain for multiple applications. Ingress allows you to terminate SSL centrally, and it also allows you to do routing rules easily. And that's why Ingress has come to stay. And like I mentioned, I said that the Ingress is that Kubernetes resource. So there's something behind the scene. There's something that drives Ingress. There's something that makes Ingress work, and that thing is the Ingress controller. So the Ingress controller is that engine behind the scenes that makes Ingress work. It reads Ingress rules and configure things like a reverse proxy to handle the traffic. So basically, the Ingress controller does the work of, in fact, one of the work is to do load balancing. It does all those, F5, the type of load balancers that we have, the work that F5 would do, the work that the Cisco load balancer would do, right? So Ingress controller does that for you. So it's the machine, it's the engine that makes Ingress work. And we have different types of Ingress controller. We have the Nginx type, we have the traffic, we have the Kong, we have the AWS ALB, that's application load balancer, Ingress controller. We have many more Ingress controllers. And for our focus, we're going to be using the Nginx Ingress controller. And for the Nginx Ingress controller, there are two types. We have the community version and we also have the Nginx incorporation version. So the community version is the one that is maintained by Kubernetes, and the Nginx one is the one that is maintained by the Nginx company itself. So yeah, so basically that's the relationship between the Ingress and the Ingress controller. And in the middle of the demo, in the course of the demo, we're also going to look at what meta load balancer is. So having understood the subject matter, let's get to the demo immediately. All right. So installing Nginx Ingress controller is pretty straightforward. And here's the installation guide. So you can check this link. I'm going to be dropping the link to this particular document in the description box below so that you can follow through. And here in the installation guide, you can install the controller either with M, or you can do a direct Kubernetes apply using the YAML manifest. So if you look at the website here, you can see that here I said that the Ingress controller can be deployed with a direct apply of the YAML manifest. And to do that, you can just run this command. And if you don't want to use this method, you can use the M method, which is what I used. I've done it and we're also going to be doing it again. So to use M, you can, of course, you need to have M installed on your Kubernetes cluster, and then you can add the Ingress Nginx M repository. And to do that, you can just copy this command here to say mrepo add, and on your Kubernetes cluster, you can then try and add it. So you can see that it's been added. So it's keeping because, like I said, I've done this before. And the next step you can take is to verify that the repo has been added. And if I do mrepo list, and if I come here, you can see that I have this repo being added, which is the Ingress Nginx. And of course, the recommended thing to do is to always update your repository. You can run this command to update your repository. And the next step to take is to check for the available Ingress Nginx versions, right? So this command would give you the 5 versions. Yeah, but because I know the version I want, then I can just go to the fourth step. That's step 4, which is to install the Nginx controller by using M. And then I can copy this command and install it. And also, I think I mentioned here that you can also add the debug option if you want to. But when you copy this command and you slam it here, you're going to get all this information to say that the controller has been deployed. And it's going to give you an example of how to write your Ingress resource. So I've done this before, but let's do it again. Um, so while this is running, the next thing you can do is to verify that the Nginx controller pod is running. So this is taking a bit of time. I've done it before, so I can just cancel it. And like I said, so it's even trying to upgrade. Like I mentioned, it's going to install the controller for you. And with this command, we can verify that the pod for the Nginx controller is running. And you can see that it's running here. Uh, okay, it's running. I'm looking at this. I hope you can see. So I think because of what I ran, it just wanted to do another upgrade, but that's fine. And this is what matters, which is the fact that the pod is running. And the next step you can take is to verify the controller services. So for the Nginx controller services, you would have the load balancer type and the cluster IP type. So if I do that here, you can see that I have two types, which is the load balancer and the cluster IP. So this is where I mentioned that I will talk about the Meta LB. If you look at the screenshot here, you will see that here on the external IP for the load balancer type of service for Ingress, you can see that the external IP is pending. And that's because, so if you look at what I have here, there is an IP. And I have an IP because I have already configured the Meta load balancer. Yeah, so because I'm using the self-managed Kubernetes, right, you would need an application to be able to give or assign your Nginx a load balancer IP. And because I am on premise, I there's an application that can do that for you, which is the Meta load balancer. If I were on a cloud service provider like AWS, I don't need to do I don't need to install the Meta LB because that load balancer on AWS I can buy or purchase a load balancer and configure a load balancer. It will automatically assign an external IP, right, for my load balancer type of service. And because I'm not on a cloud service provider, I am on premise, I need to look for another solution to be able to do that for me. And that's why I have Meta Load Balancer. So I'm going to show you the step-by-step guide of how to install Meta Load Balancer. By the time you have your Meta Load Balancer installed, then you would also have your load balancer here. It's gonna obtain an IP address. So what is Meta Load Balancer? And like I mentioned here, it's an implementation designed specifically for a bare metal Kubernetes clusters, and it works in two modes. If you look at here, you can see that I wrote here that the Meta Load Balancer works in two modes. It works with the it works in the layer 2 mode and it also works in the BGP mode. And in this deployment, we're going to be configuring that of the layer 2 mode. Like I said, you can read further. I'll be dropping the link to this documentation in the description box below. And this is how you can install Meta Load Balancer. This is the official URL, and this is how you can install it. The first step you will need to take in installing the Meta Load Balancer is to enable strict ARP for IPVS mode. So meaning that if your Kubernetes cluster uses the if your cluster uses kube proxy in the IPVS mode, you must enable strict RP. But for my own cluster, it's not actually using it. Or I still did enable strict RP. So here if I run this command here, okay, I've done a lot of things and that's why you're seeing a lot of output here. But normally in your environment, if you're doing it for the first time, you're going to see something like this, which means that if it doesn't give you any output, it means that your cluster doesn't use the kube proxy in the IPVS mode. But again, it's something you can do. Like I said, my cluster is not using it, but I still did it. And for you to be able to do it, right, you can follow this step. So to enable street app, you can edit the config map in the keep system namespace, and this is all what you need to add. That is street RP true. And if you don't want to do that, I need to reload this page again. So if you don't want to do that, you can run a script that would help you to do that. So Like I said here, you can also automate the step with the following command. So just copy this as it is and slam it here. It's going to enable the street RP, which is also what I'm going to do again. So look at what I did here. You're gonna have all these different output here. Yeah, of course, can do it again. It won't spoil anything. No, this is not what I'm looking for. So I can just copy this again. Yeah, it won't destroy anything I've configured. So yeah, basically, and it's also going to apply that in the keep system namespace. And that's the first step you need to do for you to be able to configure Meta Load Balancer. Then after which you then need to install the Meta Load Balancer using the YAML manifest file. To do that, first you need to create a namespace called Meta Load Balancer system, which is going to tell me that it already exists because I've done that. And then you can use this command to deploy Meta Load Balancer using the official manifest, right? So this is going to deploy Meta Load Balancer, and you can also verify that the pod is up. So let's verify that the pod is up. So you can see that the Meta Load Balancer ports are up. Of course, I have 4 nodes in this cluster, 2 master nodes and 2 worker nodes, and that's why you can see that I have 4 Meta Load Balancer speakers here, and I also have the Meta Load Balancer controller. And the third thing you need to do is to configure IP address pool for Meta Load Balancer. So to do that, yeah, what I did here was to use, yeah, if you look at what I did here when I applied the manifest file, I created an IP address pool and the advertisement config file, and I did, oh, okay, I see what I did here. I thought I did it with M, but I didn't do that. So of course you can also do this. You create this file in your environment, and then you can apply the configuration of that file. So it's going to create the L2 advertisement resource, and also it's going to assign this IPs. So meaning that you're going to be reserving these IPs for your Meta Load Balancer. And in my environment, like I said, you need to adjust this to your network. So here in my environment, I'm using 170 to 173. That's 170, 123, 4 IPs address. I'm reserving 4 IP addresses for the Meta Load Balancer. And that's why you see that my Ingress picked one of these IP addresses. So you can adjust that to your environment too as well. And after you're done applying the manifest, then you can verify that the resources have been created. So if I do get CRD, that's custom resource definition, you can see when I created this, you can get CRD for auto advertisement. So this is just for verification purposes and for the Meta Load Balancer. Yeah, so basically that's how you would install Meta Load Balancer using the direct apply YAML manifest. Yes, I remember, I think, like I said, I used M. So this is how you would use M, right? M repo add Meta Load Balancer, you confirm, you verify that the repo has been added, and then you can update your M repository, and then you can create the custom value schema file, right, which is this, and then you can install Meta Load Balancer with M. So this file you have here is what is being written here, right? So you just follow, if you follow it step by step, you would be able to configure Meta Load Balancer. Then after which you can verify that the ports for the Meta Load Balancer system are running, which we've already done here. So you can do it either via direct apply or using the M chart. Okay, so again, you need to go if you're using mchat, you need to also manually add the IP address pool and the L2 advertisement manually. So basically, that's how you're going to configure the meta load balancer. After that is done, like I mentioned there, then you can continue with your Ingress controller deployment, right? So as soon as you configure your meta load balancer and you then run this command, right, you immediately see an IP address assigned to your Ingress Nginx controller, which, like I mentioned, my IP was between 14.170 to 14.173, and it has peaked 14.170. So when we get to Istio deployment too as well, of course, because we are using Kubernetes on premise, Istio 2 would also need the meta load balancer. Yeah, so basically that's how you configure your Nginx Ingress controller. And the next thing we need to do is to look at how we can expose application externally by using the Ingress resource. All right. So we're going to create a YAML manifest file for the a Go application. So here, this is what I have here. It's going to create a namespace called QA and then a deployment. And this is going to be the name of the deployment and the namespace QA. And my container image is in my repository, Docker repository or Docker registry. You can also make use of the same container image. You can also pull from that same place. So this is just a simple Go application. And now what I'm going to do is to copy the YAML manifest file. So I can just copy this. Then this manifest file to be create a service as well. So I can say Go application, and then I can paste this here to enter, and I can apply the file. Say apply file go up .yaml. So you can see that some resources has been created. So let's go back here. The namespace has been created, the deployment has been created, and the service too has been created. So I can do kubectl get port in the namespace QA. You can see that the pod is already running, and I can also say get service in the namespace QA. You can also see that the service is running. However, this service is using a cluster IP, and we need to expose this service, and that's why we now need an Ingress resource. And if you scroll down here, so this is just to verify that the pod has been created and it's running. This is to verify the service that we have done. And now we need an Ingress file, an Ingress resource to expose the application. And if you look at this manifest for Ingress, you can see what I mentioned, what I said at the beginning of this lesson, that Ingress is a resource and the kind here is Ingress. And here is to enforce HTTP to redirect to HTTPS. And if you look at what I also mentioned about the types of Ingress controller, so this parameter specifies that we're using the Nginx Ingress controller. If you're using another type of Ingress controller, you're gonna specify that here too as well. And yeah, so what I'm going to do is I'm going to use the same as it is. Yeah, but let's deploy this before I say what I want to say. Let me just copy this. It's very straightforward, and that's why when we deploy the Ingress controller, we had an example of how to use the ingress resource. So I can say insert and copy in this, and then I can say keep CTL, apply for ingress, go up here now, and now you can see that the ingress has been created. So I can say keep CTL get ingress. So you can now see that the ingress has been the ingress resource has been created, and you can see the host. So that means if I call on goapp.techni.com outside of this Kubernetes cluster, I'll be able to reach the application. And you can see that I also have an address, an IP address, which is what the Meta LB has been able to do for me. And what I did, so in your environment, you will need to, if you're using a DNS server, you need to create an A record to map this host name to this IP address. So that's what you need to do. And if you don't have a DNS server, you can do that on your host file too as well. And if you look at let me see something here. Okay, all right. I was just checking something here. Okay, so if you look at what I have here, it's the same thing, verify that ingress resource has been created and verify that the application is reachable. So for me, because of how sensitive my environment is, I will not be able to show you that. And that's because if you look at what I have here when I verified, when you verify, this is what the application would show to you. It's just a test application, nothing much. So I opened a browser and I verified. And you can see I did go app dot. So there is a DNS, there is a DNS name here. There is a domain name here rather that is very sensitive and I can't show it to you. But what I did was I made sure that I edited this file to, you know, I just removed the DNS name here. And if you do this, if you follow the same step, you will have the same result. So I'm just going to clear my screen, and if you come here to, here the application is not secured. So what I did again was to get an SSL certificate. That's to, you need to definitely in a production environment, you need to protect the part, you need to protect the application. So here I have a wide SSL certificate, a wildcard SSL certificate, and it was obtained from GoDaddy. So this is the certificate, and what I did was to create a secret with the certificate, which I have done here. And you can see that the secret was created, and I also verified that the secret has been created. And then I reapplied the ingress resource YAML manifest file, and then I tested again. Now you can see that the application has been secured. Yeah, so basically that's how you can secure your application. You just need to create a secret with the SSL certificate that you've obtained. So if you're using a self-signed certificate, all good. If you're going to purchase one, all good. So this is how you can use Ingress controller and Meta LB in Kubernetes cluster. Thank you for watching. Please subscribe, like, share, comment. When you do this, you would encourage us to do more of this video, and bye for now.